Here is something about the character data type which you did not know. Typically, when I want to store a character value, then I use the single quotes and then a single character between. But I can also use a number to be stored in this value. So let's say minus 67. And this is completely valid syntax. Now, how can exactly this number be stored as a character? This is where we get to the concept of ASCII values and Unicode values. Every single character has an implicit number that is tied to them. And when it is printed to terminal, then that implicit number is usually referred to when we want to print that particular character and display it on the screen. Let's say this value, character X equals 67, and I want to print this value to the terminal. If I want to print the integer value of this, then I can do printf with two parentheses and a semicolon, and I type it as %d and x. And this will actually print this as an integer itself. Now let's say I want to get the exact value of what this number represents in Unicode. Then I type printf with two parentheses and a semicolon, and I go %c for char x. The prefix a space next to it so that we'll be able to distinguish this when we type it into the terminal. Save this. We first compile this, then we run this. We see that we get the integer value and then the corresponding character value using the Unicode or the ASCII format. And turns out 67 is actually representing the letter capital C. If I want to change this to, let's say, 72, and then I save this, I compile it again, and I run it, the number value is 72, and its corresponding Unicode character is the letter H. Now this stores 1 byte worth of data. That means it can go from negative 127 all the way to 120. I think I messed it up. It's from negative 128 and goes all the way to 127. So we can now also represent characters as integers themselves. If you want a full list of all the Unicode or ASCII characters, I'll link their Wikipedia tables in the description. Go have a look at them.